Hello everyone, welcome back. To my regular viewers and subscribers, you probably are wondering why there is a new video in the middle of our statistical analysis series. Well, I am inserting this because I see quite a few requests on this topic about, okay, I'm still confused about classes, and if I can use functions, why do I need classes? I'm confused about this init and self, and I'm not feeling comfortable. I don't blame you. I was the same way when I was started learning about about these concepts. And in fact, I get these not just from our from my viewers, but also I teach Python over the weekend to kids and a few adults, and I get this question quite often, and I see the students often get stuck at this specific part, and I developed certain training material for them, and I thought, why not just talk about it to the world? And this is exactly my attempt at doing that. So let's continue. But if you're not a subscriber yet, this would be a great time to hit the pause button and try to find that subscribe button, and if you're feeling extra generous, the little thanks button right next to it. Okay, let's jump into the code and walk through it. As usual, the link to the code can be found down under the description, so go ahead and download the code and feel free to practice it at your own time. Okay, so now since we asked the question, why do we need classes if we can use functions? Let's first start looking at the functions. And of course, you probably know what functions are. That's why you're asking this question. A function is a block of code that allows us to do a given task multiple times. And a function can take various arguments. In this example, it's taking name, age, and grade as, let's call it input. And it uses these arguments or these variables, inside this function. In this case, it's not doing much. It's just taking in these name, age, and grade as input, and it's printing exactly the same. So name, and so on. That's it. That's what this function is doing. Okay, now let's go ahead and do this for a couple of students. For student number 1, we assign a variable for name, assign a variable for age and grade, and Alice 14 and A. And now to print these, all we need to do is call this function, print student, and then provide the right arguments, and then it just prints it. Similarly, for student 2, you do that and it prints it. So there you go, student A, student B. Get it? And of course, we have this separator between these two. That's what you're seeing down here. I think you're all clear up to this point. So what's the point of classes then? I mean, this is working great. Well, it's working great, but I think it's a bit clumsy because you have multiple variables. You have to define these 3 variables each time you define a student. So can this be a bit simpler? Well, if you really hate classes, a simpler way of doing this is just define a dictionary. A dictionary is nothing but, you have a key and a value for that key. So that's exactly what we do in the next part. So instead of defining these 3 separate variables for each student, let's actually create one variable, which is a dictionary, and define name Alice, like for the key name. For student 1, the value is Alice, age is 14, grade is A. Similarly, for student 2, you have these. And the function in this case, we modified this function to actually look inside whatever that dictionary is. See, we are only passing the dictionary here, and we're not passing the 3 separate individual variables. So that makes code a bit simpler. Now you're just picking inside the dictionary and using the keys to extract the values to print them down here. So this is also fine. It works great, as you can see. Now, of course, dictionaries help you group this related information together, but what if you want to add an action? For example, what if you want to update the grade of one of these from A to A plus, for example? So how do you do that? Well, to do that, you now have to define another function to update the grade. And in this case, it takes the dictionary as an input and whatever the new grade that you want to assign to that specific student. And inside the function, of course, we are looking at the grade and assigning a new grade. So that's now you have 2 functions, one for printing the student and another one, again, for updating the grade. Nothing wrong with this. Again, you can just get away by using functions. But let's see how. You define student 1, student 2. Of course, print student is the first function, so it's going to print. And update grade. Now we are supplying student 2 this dictionary. And we are updating the grade from B to A plus, and you're printing the student 2, and we should see A plus right there. Everything is working fine. Okay, now let's look at the need for classes or objects actually. But what we need is an object, and classes allow us to actually create these objects. So imagine if the student knew how to print itself and update its own grade. What I mean by that is, imagine an object called student, and that student knows what the name is, age is, and everything. And then when you say, hey student, go ahead and update the grade, and student is like, okay, I'm going to update the grade, right? So all in one object. So you don't have these extra functions floating around. That's exactly what we can achieve with classes. Now, there are two key aspects that you will see, like two key things. Like if you look at this class, init and self. This is where I see a lot of confusion. At least that's where I get a lot of questions, at least from my students. And init is the constructor. It constructs the object for you. So if you think of this class as a blueprint, right? I mean, it's a blueprint that allows you to create different objects based on whatever you define in the inside the class. So when you make an object from that class, then you have a student 1, for example. Student 1 is Alice, who's 14, and current grade is A. Python automatically calls this function called init right there. And it's like, as I mentioned, it's like the setup step. It takes the information that comes from this init function. You see the information right there, name, age, and grade. That information goes in and stores that inside this object. Okay, and at the end of the day, init is basically initializing the object with some starting data. And now you can take that object and update stuff, for lack of a better word. Okay, now let's think of the next. And I'll show you a couple of examples, and hopefully things make more sense if you're still confused. Self is a conventional name. Remember, it's a conventional name. I'll explain more about that at the end of this tutorial. So think of it as, okay, you're using self as the first parameter for any instance method, including the init constructor. In other words, in simple terms, in a class, you can have multiple functions, and each function takes in certain arguments, and self is the first argument that you actually provide to these functions, including the init. You may have other functions, we'll see that later, but that is the first parameter of any instance method. And I apologize if I mix parameter, argument, and everything. I hope I'm making sense right here. So whatever the inputs that go into this function, the first parameter that actually goes into that function is self, and the other ones are basically the other ones that go in. So they can be in any other order, it doesn't matter, but self is the first one that actually goes in. And it actually refers to a specific instance. That means if when it's student 1, that self basically refers to Alice, who is 14, and with a current grade of A. That's what that self means. So let's look at how we define a class. So here we define a class called student. And currently it only has one function, which is just the initialize function that takes in self, name, age, and grade. Okay. Now, as soon as the student is created, the following part actually runs, which means self.name, which means it's not just any name, it's self.name for that specific object. Now I'm me. My name is whatever the name that comes in. When I say my name for that specific object, object 1, student 1 is your object 1. So student 1 has a name, age, and grade, and that's why you say self.name, self.age, self.grade. They all correspond to student 1. Now you run this again to define student 2, then student 2's self.name would be whatever that name is, age, and grade is. You can see that clearly right here. You're calling the student class, and you're supplying these 3 parameters, right, as input. That means student 1 has this name, that age, and that grade. I hope that makes sense. And student 2 has different name and age and grade right there. Now, when you print this, you can see how I am printing. Student1 has all these attributes. That object has all of these attributes already associated, so I don't need to do anything else. All I need to do is, hey, what is student1 dot name? Student1 dot age. You see, instead of self, I'm putting student1 dot name, student1 dot grade. That's exactly what self actually does. So whatever object you have, dot grade, it gives you that specific grade, and we are defining that by actually providing these as input in the init and then defining it down here. I hope that makes sense. Let's add a behavior to further unravel what's going on here. So earlier we looked at the dictionary approach where we say, okay, I want to update the grade from B to A plus, for example. Now let's see how it can be easier and using the methods. And when I say method, this is nothing but a function inside a class. A method is a function inside a class, which is in the, we'll have a look at that in a second. And they automatically get self as the first argument. So when you define a method, a function inside a class, the first argument is self. By that, we already tell the method whatever information we actually stored inside that object. So the method knows that. It knows that information. So that's how we provide that information. And adding a student is one line instead of all these multiple variables. Instead of reading the text, let me show you. How did we do this earlier? We have student1, that's the dictionary. And now, and we had a function called update grade where it takes in this dictionary as input, and then our new grade as input, and we are assigning that new grade right there. And we call the update grade function and provide our dictionary and new grade, and we print this. And of course we just did this so you know what we are talking about. Now with classes, you don't have these functions floating around. That's the key reason why at least I love using classes, which is otherwise you have way too many functions outside, and then you change one and there is in class everything is at one place. Yeah, at least for clean code, classes can definitely help. Of course, they're much better. It makes your life much easier in many other ways. But if you want your code to be clean and easy, classes can be a good way. So how do we do that? Well, we had this before, right? We had this earlier where we start with init. Now we are adding another function called update grade. Previously that update grade was just hanging outside, with no relation to this other function of printing the name and age and everything. Now this update grade is part of the student class, and the first parameter is self and the next one is new grade. It's very similar to here. The first is student dictionary in this case, and new grade right there. In this case, we don't have dictionary anymore. We have, basically the object, the self, and then we say, hey, I know you have that grade attribute right there. Go ahead and update that with the new grade that I'm providing down here. So once you define this object, Alice 14A or Bob 15B, now you're saying, okay, for Bob, because we provide Bob's input right there, for Bob via student2, for Bob, go ahead and update the grade and provide the new grade. I think when you look down here, it makes more sense. Student1, again, how do we define student? And you give these input parameters. Student2, student input parameters. Now you have two objects, student1 and student2. Now, for each object, you can actually apply these methods of updating the grade. So student1, update grade A+, student2, update grade B+, and when you print it, you get let's run it. You get Alice A+, Bob B+. It's that easy. So now that the class is defined, I just need to change, it's very easy for me to define objects and update whatever, parameters I need to update right there. Now, I'm actually adding print statements outside. Normally, you would add print statements inside this class, so you don't even need to say print. That's at least typically that's exactly what I do. So in addition to update grade and initialization, I'm actually printing info. So right after initialization, go ahead and print whatever we have and then update this grade right there. So when I call student one, it's creating student one object, student two object. Now student one and print info. I'm calling this method. I almost said function there, but I'm calling this method because it's inside a class. It prints it and then updates the grade and prints the information again. There you go. So this part, it actually printed right here initially, and now I updated the grade to A plus, and it's actually printing Bob's grade as A plus right here. Okay. Now, the summary is with dictionary approach, every time you want to change something, you must find the right tool, like write a right function and give it the object. With the class approach, the object actually has its own tools. I don't want to get into how you can find what tools are available, meaning what methods are available and all that. Look at the documentation. But the core point is once you create an object, it actually brings all the attributes, all the stuff with it. So we just need to call and then update. That's it. You don't need to refer to something external. Now, at the end, explaining it simply, a class is basically a toolbox for a certain type of object, right? And inside this toolbox are methods and that know how to work with that specific object data. Now, let me move on. And if you're still confused about this self part, I mean, I hope I thought I did a good job explaining self, which is basically it's a specific object, specific instance, right? So sometimes, I don't know about you, but I learn when stuff fails. I don't learn very well when stuff works fine. I learn when it fails, and then I'm like, what is going on here? I start digging in, and then oh, okay, I was stupid or whatever. That's where you learn. And here, that's what I'm trying to do. Previously, we had self.name, self.age. So now if you run it, it's okay. So code runs fine. It didn't give you any errors. But now try to do this, student1.name, because you defined the student object right there, right? But because you did not put self.name, kind of created and forgot about it, if that makes sense to you. It says, hey, I don't know what you mean by student1.name because student1 has no attribute called name because we didn't do self.name. That's why it actually fails. So when we write self.name, again, I'm reiterating this because this can be very important. And self.age equals to age, we are saying store this into the object's memory. Okay. I thought I put something like, yeah, I thought this is a good analogy. Think of init as filling out a personal profile card for each student. And without self, you're just writing their name on scrap paper and you're throwing it away. Without this self.name, you're just writing it on a scrap paper, throwing it away. Because when you run it, it runs fine. But when you actually create an object, it's not part of that object. So with self, you're writing their name inside their own profile card. So when you look it up later, you can easily bring that information out. So why did this fail? So what was I trying to show you here? Self.name. Yeah, it's basically another example of showing you, okay, here you have self.name equals to name, a good student, a bad student. I am not using name, self.name right there. So when you call the good student and call the bad student, obviously it failed when it's trying to do the bad student part. So many ways I'm trying to make sure you understand this concept, and I hope it makes sense. Now, one final thing before ending. This came as a surprise to me much later. I started learning Python 10 plus years ago, literally 5 years ago or something, when I heard about, oh, self doesn't have to be self. Not that I changed my coding habits, but self is just a universally accepted convention for referring to this instant of a class. It can be anything. Instead of self, like I'm replacing self with Swayam, which is the Sanskrit for self, which is myself. Swayam means me, myself, or Swa actually is the Sanskrit word. Swayam is a Hindi or Telugu translation, or, not translation. The root word is Swa, let me put it that way, from Sanskrit. what are we doing? Sometimes I don't know why I go on this tangential routes, but anyway, let's replace the self with Swayam. So in this class of student, instead of self, I just put Swayam. Although, I mean, obviously you have to put Swayam like everywhere, right? So it's not just self.name, it's Swayam.name. It can be anything. It's like a cat, dot name. But of course, Python style guide, PEP8. I hope you're familiar with that. It kind of tells you what the good practices are, for coding. It explicitly recommends using self for the first argument. That's why we use self. But I just want to show you, you can use whatever you want and still run the code, and it still runs. Okay, so I hope at least this tutorial lives up to the title of Demystifying Classes. This is like as basic as it gets, but I seriously hope some of you at least will find this to be eye-opening and useful. Thank you guys, and please keep watching these tutorials, and do not forget to hit the subscribe button. Thank you.